Hi there everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be focusing our attention on polymers, and this is part of the GCSE chemistry topic called bonding. We are very close actually to finishing this topic. We'll be moving on to quantitative chemistry very shortly, so keep an eye out for that. Feel free to subscribe so you don't miss out on that fantastic module. I know a lot of students have inboxed me on Instagram throughout the years of that being a platform for me, but also in real life as I teach. Lots of students do ask for support with quantitative chemistry. So if you are also studying that or you would like some help, like this video so I know that I can prioritize those videos. I also have lots of revision on my Instagram and TikTok, like I said, but also here on my channel, I have lots of biology, chemistry, and physics videos. So if you are interested in learning more science and you want more support with a real science teacher, that's me, you can join us here on YouTube by subscribing. And thank you so much if you've already joined our community. It's amazing to have you here. So thank you. So, what are polymers? Well, they're very large molecules and they are essentially made up of repeating units or subunits called monomers. Those monomers are essentially connected by strong covalent bonds. And if we remember from previous videos, a covalent bond is a bond between two nonmetals that have essentially shared electrons. And those are valence electrons. They are electrons in the outer shell. And those atoms do that to gain stability. Polymers often form very long chains. Thousands of monomers are often attached or bonded together covalently to form long chains, but don't get confused that polymers actually aren't always linear. They're not always in a straight uniform line. In fact, a lot of biological polymers, such as DNA, which is obviously a double helix shape, we have amylopectin, which is a part of starch found in plants, they often are branched in their chain. So they will have also different forces of attraction, intermolecular forces, especially if there's layers of polymers that can connect them too. So polymers are very strong. They have high melting points because of those covalent bonds. Remember, a lot of energy is required to break those bonds apart. Polymers are essentially solid at room temperature, and that's just something some of the exam boards would like you to know. So, if we look in the world around us, I've already mentioned a few of these, but we can think of polymers everywhere. We obviously have starch that is found in plants. We have cellulose. We have DNA as a polymer, essentially. Those nucleotides are those repeating units. Protein is made up of amino acids, which are the monomer. Glycogen, again, made up of glucose, that is a repeated unit to make that glycogen that's found in liver and muscle cells. And also polystyrene. Polystyrene we find in cups. We often find it in other packaging and places like that. So polymers are incredibly useful because of their durability in manufacturing as well. So you've probably not thought about it, but polymers are absolutely everywhere. So, how do we draw polymers? In the exam, you could be given an example of a repeating unit, something like this, a linear polymer. And you can see that it's a hydrocarbon, it only contains hydrogen and carbon, and those carbon atoms are covalently bonded, those hydrogen atoms are covalently bonded as well. We can actually simplify this diagram by drawing essentially a polymer diagram, which looks something like this. So, we'd be given the branching or the long chain of the polymer, and we just have to simplify it. So the repeating unit or the monomer looks like this. You can see we've got two carbons covalently uh, bonded, and we've just simplified it by putting brackets around it. Those lines that cross over the bracket, you must make sure cross over. That is one of the marks in the exam. And the N on the bottom right hand side essentially just means the number of repeating units. So in this case, you can see we've got 1, 2, 3, 4. We could put N as number 4 in this case. Okay, so another variation of this is actually using the monomer that you're given in the exam to draw the polymer. So we can see we've been given a monomer, for example, chloroethene. The ethene is the two carbons. That's where ethene comes from. Because it's ethene, it's got a double bond. So ethane would have one bond for the carbon atoms, but in this case, there's two. There's a double carbon covalent bond, so it's ethene. Chloro obviously comes from the chlorine atom that you can see on the bottom right. Remember, each carbon atom is able to create 4 covalent bonds. So each carbon, if you look at it, we've got one of the carbons on the left bonded to the carbon on the right, so that's 2, 3 with the hydrogen, and 4th with the other hydrogen. And then the chlorine on the other side, you can see it's got 1 covalent bond on the right, 2 with the carbon on the left, and 1 with the chlorine on the right as well. So that makes a total of 4 for each of those carbon atoms. When we draw the polymer of this, we need to open up that double bond, and that way we can actually extend those bonds across the bracket. That will, again, like I say, give you a mark in the exam. We also, although the monomer has this kind of angled bond you see there, we actually want to draw them upright and at 90-degree angles. That is something they also look for in the exam, so be careful of that when you draw it. Poly, by the way, where it says polychloroethene, poly just means many. If they asked you to do chloroethene that contained 20, you'd put, instead of N, you'd just put 20. But in this case, I haven't necessarily asked that. So I've just asked for the polymer, and poly would be fine. So here's another example that I'd like you to have a go at. It's going to be kind of a bit harder for you to comment below for this one, but you can definitely write it down. You can obviously comment below if you find this helpful. If you've enjoyed the video so far, let me know. But it'll be a bit hard to actually comment this one down in the comments, but you can obviously write this down in your own note and paper. How do you do this one? So we've got propene monomer. Propene, remember, it's an alkene because it's got that saturated double bond. What do you think the answer is? I'll show you on the next slide. So here we go. We have polypropene. So we've just opened up that double bond. We have our CH3. This one's a bit trickier this time because we've actually almost condensed that CH3. What we've done is you want to make sure that your carbons are in the center. That double bond is in the center. You might be thinking, well, why didn't we have the carbon double bond at the bottom with a CH2? Well, that is because of the double bond. We want to open up that double bond. So just be aware of that. CH3 is at the bottom right, and then the N is at the bottom right as well. Don't forget the brackets. Those are the things you're looking for the most. I hope you found that video helpful. If you did, feel free to like, comment, and subscribe. I have been the GCSE science teacher, and you have been curious. Thank you so much for your time. Keep an eye out for those quantitative chemistry videos that will be dropping very soon on my channel, and I will catch you in the next one.